Hello everyone. Let's start with the discussion of the NEET paper, which was this year. To give a brief to everybody with respect to the paper, it was a paper which was properly from all the inside parts of the NCERT with respect to all the theoretical chapters. The numericals were somewhat direct and the paper was quite tricky. So if not read properly, it would have led to you losing marks over there. Let's discuss right away. To start with the first part over there, it says gadolinium has low value of third IE because of. Here the answer is simple. It's because of its high exchange energy, that is due to the stability of what we have as nothing but empty, half-filled and completely filled orbitals, where we know the stability rule is because of two factors. One, the symmetrical distribution of electrons and the exchange energy. So here, because of La, Gd, Lu, which are empty, half-filled and completely filled, you can explain the stability due to the high exchange energy. That is the second one there. The next one comes, which of the following is not correct expression with respect to Dalton's law. Now, Dalton's law of partial pressure is basically you sum up all the partial pressures, and partial pressure of any component is nothing but the vapor pressure of the pure component multiplied by its mole fraction. Sum of all the partial pressures will give you the total pressure. So that can be expressed in terms of one, the first one, that's all the pressure, or in terms of the ideal gas equation, that is 2, which is PV is equal to nRT, or it can also be expressed over there if you observe in terms of nothing but the third one, in terms of the third one also, that is Pi is equal to X1 and P over there, where P is the total with respect to I number of moles of gas. The last one is not the correct one. The reason is because they have said Pi is equal to Xi into Pi naught. It cannot be naught. Naught is with respect to the pure components. All right. So it has to be with respect to the total partial pressures. So here the fourth one is not the correct expression. This is the entire part which is given in the NCERT. If anybody observes, the whole calculation, everything is explained over here. This is in terms of the states of matter chapter. Then comes next one, the assertion and reason questions over there. It says there are two statements. In a particular point defect, the ionic solid is electrically neutral, even if few of the cations are missing from its unit cells. And the reason is, it says in Frankel defect arises due to dislocation of cations from its latticed sites of the interstitial, from latticed sites to the interstitial sites, maintaining the overall electrical neutrality. Now here, if you observe in this category, then in this category, what is trying to say? Here, the correct answer is nothing but the second option, where assertion and reason both are correct, but the reason is not the correct explanation of the first part. That's one. So that's your 53rd one. Then 54 is a direct one, calculation of a P of H, where they have given you sodium acetate and acetic acid. Acetic acid and sodium acetate is an acidic buffer, weak acid and a salt of its strong base. So the formula P of H is equal to P of Ka plus log of active mass of salt upon the active mass of acid. If you see the 54th one, that's the working part over there. So that P of H comes as 5.57. So 54th is the first one. Then 55th one, again, it says identify the incorrect statement. Here the incorrect statement is the second one, where it says the oxidation state of potassium in KO2 is +4. That's wrong. KO2 is potassium superoxide, which is used in the submarines, all right, to liberate oxygen gas. Here, in the superoxide, each oxygen is in oxidation state of -½ and potassium being an alkali metal of group 1, its oxidation state is +1. So that's the incorrect part. So 55, that answer is 2 over there. Sorry. 56, again, two statements. The acidic strength of mono-substituted nitrophenol is higher than that of phenol because of electron withdrawing nitro group. That's correct, because more the presence of group showing -I effect, we say in phenols, the acidic strength increases, and group showing +I effect will decrease the acidic strength. Second, it says ortho, meta and para-nitrophenol will have the same acidic strength. That's a false statement. So in the first case, statement 1 is correct, statement 2 is false over there. So statement 1 is correct, but statement 2 is incorrect. So 56 answer is 3, where Look at the acidic strength. We know groups showing minus I effect. If they are at the ortho and para positions, it increases their acidic strength. So para-nitrophenol is more acidic than ortho and then meta, where the P of Ka values are there, where we know about the P of Ka. Larger the Ka, lower is the P of Ka, and that acid is stronger. And that is with respect to the formula. P of Ka is minus log of Ka to the base 10. That's one. 56th one. 57th one. What mass of 95% pure calcium carbonate will be required to neutralize 50 ml of 0.5 molar HCl? Now, this is a similar question what is in the exercise questions of the first chapter. That is some basic concepts of chemistry. That's the mole concept part. This answer comes as second one, 1.32. Look at the working please. 57th, as per the reaction, we all know number of moles, concentration C is equal to N by V. So number of moles when we are talking over there, that's M1 V1, normally what we try to do. So that's one. So number of moles, what we have is the molarity into its volume. Volume was in ml, so you convert it to respective liters, you got the moles. Now, as per the balanced equation, 1 mole of calcium carbonate corresponds to 2 moles of HCl. So 0.025 moles will correspond to how much? We get the moles of calcium carbonate. Molar mass of calcium carbonate is 100 grams per mole. All right. Calcium atomic mass is 40. Carbon is 12. Oxygen is 16 into 3. That's going to be over there nothing but 48. 48 plus 12. That'll be 60 plus 40, 100. Now, mass of pure calcium carbonate will be nothing but the molar mass into the moles. That is 1.25 grams. Now it is said calcium carbonate is only 95% pure. So mass of 95% pure will be 1.32 grams. That's one. Then the IUPAC name of the element with atomic number 119, that's going to be anium. Un is for 1. Is clear? Again, un is for 1. And for 9, we write the word N, E-double-N. And the end, you sum it up with IUM. So if you see the NCERT table, they have given till 118 as per the periodic table. But for 119 and all, there's a small table given where they have said if it is matlab 11, then we write the word N. Then 12, we write do. Tri, then 13 is tri, tetra, penta, hexa, hepta, octa, and 9 is not nona, it's N, E-double-N. So then 119 will be first one, anium. Then choose the correct statement over here. Now we are in this case, graphite and diamond, both are three-dimensional. Then diamond is covalent and graphite is ionic. Both are covalent in nature, so second statement is also false. Third one is the right statement where it says diamond is sp3 hybridized because of a giant network structure, and graphite is sp2, which is in the form of nothing but we have as the planar rings over there, what we call. And last, both are used as dry lubricants. It's only graphite which is used as dry lubricant in machines. So 59 is the third one. So that's one. Okay, 59th one. Then 60th question. Statements are given about the coagulation of a negatively charged salt. That's in terms with Hardy-Schulz rule. Higher the charge on the ion, more is its coagulating power. So for negatively charged, we say positive. For negatively charged salt, positive ions with a higher charge will have greater coagulating power. So aluminium, barium, sodium. So this order is correct. Second statement, coagulation of positively charged salt. You require a negatively charged ions where they have given the order. This is a false order because in chlorides, you have to just take the anions because it's positive salt. Chloride is -1, sulfate is -2, and phosphate is -3. So the order has to be ulta. Sodium phosphate greater than sodium sulfate greater than NaCl. So in this, statement 1 is correct. Statement 2 is false. Yes. So 60th one, answer is the third one. That's in line with Hardy-Schulz rule. Okay. Then 61st question with respect to the PV curve, that is the pressure volume curve, which represents maximum work. Now, maximum work done, if you observe, is always with respect to an isothermal and a reversible process. Reversible process, which takes place infinitesimally slowly with infinite number of steps, then the work done is maximum. So whatever is the work done, we shade it up. So this clearly shows the answer is going to be B over there. All right. So that's 61B, maximum work. That is the second one, sorry. 61B, that's the second. Then 63rd, 62nd, sorry. 62nd, if you see, it says aliphatic, primary aliphatic amines react with HNO2 to give unstable diazonium salt. That's true. Why? The diazonium salt will decompose to liberate nitrogen gas and give its respective alcohol. That's one. So first statement is true. Second statement, it says aromatic primary amines react with HNO2 to form diazonium salts, which are stable even above 300 Kelvin. That's a false statement. Diazonium salt, aromatic diazonium salts, we talk their stability is always between 273 to 278 Kelvin, which is precisely 0 to 5 degrees. So here again, statement 1 is correct. Is this clear? But statement 2 is incorrect. So this is also 3. So 62 is 3. That's one. Then comes 63rd one. 63rd, it says which of the following is incorrect statement. This is all about the MOT part. Now all are true except one, that is the fourth one. O2 plus, it says, is diamagnetic. It is paramagnetic ion. I've given the configuration of MOT with respect to all the ions, O2 plus, O2, O2 minus, O2, 2 minus, C2, H2 plus, as well as O2 plus here. Please have a look at it. For O2 plus, the bond order is 2.5. I've given its configuration and it's paramagnetic. Oxygen, bond order is 2. It's also paramagnetic. O2 minus, bond order is 1.5. It's paramagnetic. O2 2 minus, the bond order is 1. It is diamagnetic. C2, the bond order is 2. It is diamagnetic. And H2 plus, that bond order is half. It is paramagnetic. So here the incorrect one was nothing but the fourth one. So that's 63. Then 64th RMGX plus CO2. This is with dry ice, what we also call as carbonation of Grignard's reagent. It says what is Y? That's your magnesium intermediate complex. Now the magnesium intermediate complex is mainly RCO minus and MgX plus over there. So that's the first one there. So 64 is 1. That's the part. This is exactly the same general reaction which is given in the NCERT in aldehydes, ketones, and carboxylic acids. So those who have read the NCERT properly 3 to 4 times, they are the ones, they'll be able to get it all correct. Otherwise, it's highly tricky paper. Next one. 65th one. Regarding polymers is not correct. Now, not correct is basically, it says thermosetting polymers are reusable. They cannot be reused. Like bakelite, the phenol formaldehyde resins, they cannot be reused. So they are saying it's reusable is a wrong statement. So 65 is the fourth one. Then 66th one, it says they have given the E0 values here. So E0, if you see here, it is +2 to +7. Is this clear? And this is also for oxygen. If you observe, then this value is 0 to -2. Is this clear? So we are having the values where it says 2 values are given below. Now with respect to one is +2 to +7. So that's the oxidation value. Other one is the reduction value, O2 to H2O. So you convert one of the values. So when you convert one of the values, we say with respect to SRP, it's cathodic reduction minus anodic reduction. Or if you convert to oxidation, it's anodic oxidation minus cathodic oxidation. So will it liberate or no? Answer is yes, it will, because the E0 of the cell comes to be positive. Look at this. 66th one, higher SRP is the cathode and lower SRP is the anode. So here when I'm doing it, cathodic reduction, the cathode value is more with respect to oxygen, and the anode reduction value, which was minus, that will change over there because it's the, I told you, manganese, if you see Mn is shown to be +2 to +7. So this is its SOP value. +2 to +7. You have to convert it into SRP, so the value will become plus. From -1.51, it will become +1.51. So if you change that value, that answer comes to be positive. So as the E0 of the cell is positive, yes, the reaction is a spontaneous reaction. So KMNO4 will liberate oxygen. Then 67th one, it says in Geldahl's method for the estimation of nitrogen, which one of the following, which is used to estimate, which compounds can be used to estimate. This also is a paragraph in the NCERT part after the Geldahl methods get over. Okay, any of the compounds which contains the nitro group or nitrogen in the ring like pyridine or the azo group, they will not give Geldahl's test. So definitely there's only one option left which will give, that's going to be aniline. So 67 is C, or the third one, sorry. 67 is the third one. 68, the incorrect statement over here. Now it says enzymes are polysaccharides. They are mainly the biocatalyst, what we call. So this is the incorrect one. So 68 is 3. Then 69 people, the IUPAC name, it's very simple. First one is Ag with H2O twice. So diaqua. Is this clear? Because H2O is 2 times. So diaqua silver, where silver is always, we know, oxidation status +1. Now this is a neutral complex. So it will be just written as diaqua silver 1 for the first one. And the second complex, if you see, then that's an anionic complex because cyanide is going to be -1 into 2 over there. So silver ka state we all know is +1. So the complex will have a charge of -1. So the first complex, the AgH2O twice, will have a charge of +1, and AgCN CN2 the whole twice, second complex will have a charge of -1. That's why they have not shown the charges. It's understood. They, it gets neutralized. That's why the more correct name here you see is going to be D. Diaqua silver 1. Silver is in +1, and dicyanide argentate 8, because I told you, it's anionic. So technically this is with a plus charge, this is with a minus charge. An anionic complex, we end with the word 8. So 69 is 4. Then 70th one. Now here they are just given the examples, what you have to catch from. So if you see carefully, all right, 70th one, to catch this part clearly, here 70th antacids example is cimetidine, antihistamines, that's Seldane, analgesics, that's the narcotic analgesics, that's morphine, and antimicrobials, that's nothing but salvarsan, which is used for the curing of the STDs. So 70th is the second one, what we have, where we say A is the third one. All right, then B is 4, C is 2, and D is 1. Then next one, it says which one of the following will have maximum lone pair repulsion. So maximum lone pairs here is only with one compound, that is fourth one, xenon difluoride, which has a linear structure with 3 lone pairs. So look at the structure. 71 is xenon difluoride with 3 lone pairs and a linear structure. Now it says you are given the electrode potential value of all the ions, and all are in the SRP values because it's reduction values, +2 to 0, all of them. And only for silver, it is +1 to 0. Now people, with respect to SRP, what we know, element with higher SRP will undergo reduction, lower SRP will undergo oxidation. So it says which of the predict which cannot occur. Now cannot occur, if you see clearly, is going to be the D1. Why? Because silver is getting oxidized and the cupric ions are getting reduced. And technically, if you look at the values, silver has a value of plus 0.8 volts. So silver ions should technically get reduced to silver, and it should be other way around. Copper should get oxidized because cupric ions, the value is only 0.34 as compared to that of silver, which is 0.8. So the correct reaction should be copper should have got oxidized to cupric ions to form copper sulfate, and silver ions would have got reduced to silver. All right. So 72 is 4. Then 73. 73, if you observe, it says identify the incorrect statement. It says all the 5d orbitals are different in size when compared to respective 4d. Yes. Now here, if you observe clearly, there's only one statement which is incorrect. That is the fourth one. the shape of dxy, dyz, and dxz are similar. And last it says the x square minus y square and the z square are similar. Actually, the correct part is dxy, dyz, dxz, and the x square minus y square are all similar in shape. It's only the dz square, which is a double dumbbell orbital with a donut ring in between. That's the different orbital, dz square. So the incorrect is the fourth one. So 73, that's the fourth one. Okay. 74. It says in 1 molal solution, which contains 0.5 moles of solute, there has to be. Now, definition of molality is what? 1 mole of a solute in 1000 grams or 1 kg of pure solvent. So if I have 1 molal, then for 1 molal, if the solute is 0.5 moles, but obviously the solvent has to be 500 grams of pure solvent, which is nothing but 0.5 kg. So 0.5 by 0.5, that's one. This was a direct one. So 74 is 2. Then 75, it says 2 statements are given below. Assertion ICl is more reactive than iodine. If anybody has done the NCRT properly, this was the in-text question of P block group 17, which is given at the bottom over there. Okay, ICl is more reactive than iodine. Why? It says ICl bond is weaker than iodine. That's correct, because ICl bond will be weaker because II is basically 2 non-polar bonds. And in ICl, there'll be a difference in EM. So due to that, there'll be polarity, and both being halogen, chlorine being more electronegative will pull the shared pair. So the bond is weaker, it will break faster. So in this slide, what it says, the correct statement, yes, both assertion and reason are correct. And the reason is the correct explanation of assertion. So 75 is 1. That's the first part. Then 76th one, it says, which of the following compound is not an aromatic compound? Now, what are the rules for aromatic compounds? All the atoms, carbon atoms, should lie on the same plane. B, they should follow Huckel's formula, 4n plus 2 pi electrons. And third, all the carbon atoms should be sp2 hybridized. So here looking at it, the answer is nothing but is printed as ABCD. It's actually 1, 2, 3, 4. Is the fourth one. Why? Because if you look at this carbon, what I'm just putting the circle there, this carbon, the hybridized state is sp3. All should be sp2. All right. So 76 is 4. That's one. Then 77 over there, what it says, you are given 2 statements. The boiling points of hydrides of group 16 is given the order. That is one. Now this order is false order, because water will have the highest boiling point because of intermolecular hydrogen bonding. And the boiling point of the hydride increases with increase in molar mass. This is also a false statement. So here it says statement 1 is what it says, both the statement 1 and 2 are incorrect. 77 is the second one. And look at that boiling point order. Water is less than H2S, which is greater than hydrogen selenide, which is greater than hydrogen telluride. And this order, if anybody observes, it is with respect to the table which is given for group 16, where the boiling points are given and we get an idea about the order. So that's 77. Then 78, they have given with respect to the uses. That's from the S block part. Now lithium, we all know lithium ion batteries. So lithium is used in electrochemical cells. So the first one, A1, has to be 2. And A with 2, if you observe, there is only one option. And then B, sodium. That's basically used in liquid sodium is used as a coolant in fast breeder reactors. Then we have KOH, that's an absorbent for CO2. And the last one, cesium, that's basically used in photoelectric cells there. So 78 is 4. Then 79, which of the following sequence is suitable to synthesize chlorobenzene? So preparation of chlorobenzene, chapter hydrocarbons, aromatic part, electrophilic substitution reaction. That's the first one itself. That's why answer is 1. Benzene reacts with chlorine in the presence of anhydrous FeCl3, the Lewis acid catalyst, to generate the electrophile Cl plus chloronium ion, and we get the product chlorobenzene. Second one, phenol with NaNO2HCl. There is no reaction of phenol reacting with NaNO2 and HCl. Third one, benzene with HCl. Directly, there is no reaction. Is this clear what we have? Then aniline reacting with aniline with HCl heating, that is also not there. So there's only one which makes sense there. So 79 is the first one over there. Then 80th, look at that. Statements are given below. So 1 minute, 79, that's the, just look at the reaction. 79 is the first one. So benzene with chlorine with Lewis acid catalyst gives you chlorobenzene. 80th, it says the boiling point of aldehydes and ketones are greater than the hydrocarbons of comparable mass due to dipole-dipole interaction. That's correct. Aldehyde ketones don't show hydrogen bonding, but they have dipole-dipole interactions among themselves. That's correct. And the boiling point of aldehydes and ketones are lower than that of alcohols of similar mass due to absence of H bonding. Correct. Alcohols have higher boiling point. In fact, maximum boiling point is with carboxylic acids due to formation of a ring, that's dimerization. Then is alcohols, then comes aldehyde ketones part. So here we will say in this category, the boiling point was yes, both the statements are correct. So statement 1 and statement 2 both are correct. So 80th is the first one. So that's the 80th. Now 81 is with respect to the chemical properties of aldehyde ketones, cyanohydrin, that is group containing over there OH and cyanide both together. Now that is nothing but with HCN. So the first one is 4. So with first one 4, only one option makes sense. Acetyl is aldehydes or ketones reacting with alcohols. So that's 3. Skiff's base is aldehyde or ketones reacting with primary amines. That's the second one. And last is oxime formation. That is aldehydes or ketones reacting with hydroxylamine. That's NH2OH to give you respective oximes. So 81 is 4. Then 82nd one, the incorrect statement. SN1 gives 1:1 mixtures of both enantiomers, correct. 50-50, 50% dextro, 50% levo over there. So that's enantiomers, correct. If it is chiral, the product by SN2 gives chiralities with 100% inversion of configuration. That's Walden inversion. Enantiomers are superimposable mirror images on each other. This is the false one. They are actually non-superimposable mirror images of each other. One cannot be imposed over the other because they have same molar mass, but they have equal rotation on opposite directions. So 82 is the third one. All right. 83rd one, talking about the hydrides. Magnesium hydroxide, that's basically an ionic hydride. So the first one is 4. So with first one 4, only one option makes sense. Then GeH4, germanium hydride, that's electron precise because that's in group 14. That is carbon, silicon, germanium, tin, lead. Then B2H6 diborane, that's electron deficient. And HF, that's electron rich. So 83 is the first one. Then 84. Which of the following statement is not correct about diborane? Now diborane is basically 3-center 2-electron bond. That's correct. 4-terminal BH and 2-center 2-electron bond. All is fine. Only last one statement is wrong. It says both boron atoms are sp2. Actually, both the boron atoms are sp3 hybridized because it uses its vacant orbital also. So 84 is 4. '85, we have a graph of kinetics, X and Y over there. Now, if you observe carefully at constant temperature, which are the ones which make sense? Observe this carefully. First of all, zero order, where Y is the rate and X is the concentration. Then we know for zero order, the rate remains constant with respect to any concentration of reactants. So that's one part. And if it is a first order, then Y can be T half, that's half-life, and X can be concentration. For any concentration, we say the half-life remains the same because the T half is independent of its initial concentration for first order. So 85, that's the third one. All right, that's one part. Then 86, what it says, now with respect to the O's, now calamine, we all know calamine is zinc carbonate. So C has to be 2. So with C options as 2, you have 2 there. All right. And then you have last one over there as kaolinite. That's the D1 is 4 over there. So if I have C as 2 and D1 as 4, so C2 and D4, so 86 has to be 2 over there. So hematite Fe2O3, magnetite Fe3O4, calamine zinc carbonate, and kaolinite. 87, flask of 10 liters, sorry, that's the volume V. 64 gram is the weight of oxygen. Ideal gas, so the pressure of the flask. So ideal gas equation, PV is equal to nRT. So we can calculate the number of moles. So look at that. Volume is 10 liters. Number of moles is given mass upon molar mass. Oxygen molar mass is 16 into 2, O2, 32. So 2 moles. Temperature 300 Kelvin. The pressure comes as 4.98 atmospheres. So 87 is 4. Then for a first order reaction, A gives product. Initial concentration is 0.1 and it becomes 0.001 after 5 minutes. Rate constant in per minute is now a first order. K is equal to 2.303 by T log of the ratio of what we have as products upon the reactants over there. So this 88, if I have to calculate, look at that. That comes directly as 0.9212. So 88 is the second one. Then ninth one, the energy, the order of energy absorbed, which is responsible for the color of the complexes is. Now see, in this, very easy to understand. If I have a strong field ligand, then the strong field ligand will help in more splitting of the orbitals, that is the crystal field splitting, leading to DD transition. So I require orbital, I require strong field ligands. Now ene, it's basically ethylene diamine, what we have. That's what we call as En. That's a bidentate ligand. So here you have En thrice, here you have En twice, and here you have En only once. So simple, C is greater than A and A is greater than B. So it's the third one. 89 is the third one. Clear? So more the strong field ligand. So greater if it is bi, tried, like hexadentate ligand also we have, that's EDTA. So greater, more the points of attachments, that ligand is a stronger ligand, and stronger the ligand, more the CFT, crystal field splitting theory, so leading to more DD transition. And that's the reason why if there is more DD transitions of electrons, then we'll say it will be responsible for the color, because the color is always when there is splitting of the orbitals and electrons are jumping from lower to high energy levels. 89 is 3. All right. 90th people is basically calculating the Kc, that's the equilibrium constant. So Kc is nothing but, as we know, active mass of products upon the active mass of reactants. So it's O3 raised to 2 upon O2 raised to 3. You want the concentration there. So look at the working case. 90th, it is the first one. Well, look at that. O3 by 2 upon O2 raised to 3. So once you calculate, that comes as 4.38 into 10 raised to minus 32. So 90th is the first one. Then find out the EMF of the following cell reactions over here. Now here, this question is actually an ambiguous question, or you can call it as a wrong question, because what has happened is they have given the E naught of the cell as 10.5 volts. Technically a misprint, it should be 1.05 volts, because if you take 10.5, we all know how is the EMF increased. Either, what do we say? Simple understanding for the numerical part is to increase the EMF. Either you decrease the concentration of the ions which are formed at the anode, or increase the concentration of the ions which are undergoing reduction at cathode. Then the EMF will increase. All right. Here, Ag plus ions will be raised to 2. So if you calculate, that value is not coming. Have a look at it. It's a wrong question. So in the examination, this will be, while counting this question will be omitted. So out of all the questions, it will be only this question is an omitted one, which will be there. So look at that. I've written the word invalid because this is how it comes. If you calculate with respect to the active mass of logs of products upon reactant, actual value is 10.411 volts, which is not there only. But instead of that, if the E naught cell, the decimal was 1.05 volts, then yes, the answer would have been a 0.9615 volts. So that's an invalid one, 91st one. Now it says which of the following is not formed when acetone reacts with pentane 2-one in presence of acetone reacts with pentane 2-one in presence of dilute NaOH. Now here faster way to do this would be, this is basically what we are talking as cross ketol condensation what we have. So first acetone will give self condensation products, or basic, then will give pentane 2-one will give self, and then there'll be two cross. So the compound which is not formed here, if you try to see, is going to be the D1. All right. Why the D1? Observe this carefully. All right. 92, sorry, it's not the D1. Not formed is the second one, CH3, COCH3. Sorry. The B1 there. The logic here is when we try to talk in terms of the ketone part, the carbonyl group should be present on the second position. Here in this case, the carbonyl group is going on the third position. Whereas if you see the rest of them everywhere, the carbonyl group comes on the second positions. Here also it's on the second positions. In this case, it is going on the third position. So this is the product which will not be formed. So 92 is B there. That's one. Clear how to identify quickly. Okay. Then 93rd one, the correct IUPAC name. Now this is simple. OH group is more prior, so the answer has to be in terms of alkanol. So alphabetically. So first we will have alphabetically 1 bromo, all right, 5 chloro. Now 1 bromo, 5 chloro is only one option. That's option A. 1 bromo, 5 chloro, 4 methyl. That is this compound 4 methyl, and hexane 3 all. So 93 is A. Or the first one. 94. If the radius of the second orbit of helium is 105.8, what is the radius of the third orbit of lithium ion? So this is basically, we all know the formula. Look at this. 94th radius in the nth orbit is 52.9 into n square upon z. So basically the orbits you take. Now Li plus lithium. So that's going to be over there for lithium, z is equal to 2. Z is equal to, for lithium, z is 3. And for helium, it is z is 2. So for helium, the radius is given as 105.8. So for the third one, in case of lithium, will be how much? Just a cross multiplication. That's 158.7 picometers. So 94 is the first one. Then 95, compound X on ozonolysis gives a mixture of formaldehyde and 2-methyl propanol. The initial compound is. Now this is very simple. The formaldehyde, the carbonyl group double bond and 2-methyl propanol. That's why you show the double bond part and try to do it. So look at this. 95 goes like this. If the compound is 3-methyl but 1-ene, look at that. On ozonolysis, 3 oxygen, 1 in between the double bond and 2 across. And then the ozonide breaks over there, leaving 1 oxygen, which goes with zinc as Zn over there. And it gives a mixture of 2 aldehydes. So 95 is the first one. 96 in faintly or in neutral, or faintly alkaline medium, KMnO4. Now in neutral as well as in alkaline medium, KMnO4 gets converted to MnO2. So KMnO4, Mn is +7, MnO2, Mn becomes +4. So it's +7 to +4. So 96 is 1. All right. 97. That's going to be over there. The pollution due to oxides of sulfur gets enhanced due to the presence of. Now, particulate matter, yes. It's also due to ozone, that's correct, as well as due to hydrogen peroxide, which produces the free radical. It's not because of the hydrocarbons. So 97 will be 2. That's A, B, and D. Then 98 in Lucas test, one primary, secondary, tertiary alcohols can be distinguished by a mixture of conc HCl and ZnCl2, correct. Primary alcohols are most reactive and gives immediate turbidity at room temperature. This is a false one. In fact, it's other way around. 3-degree alcohols are the ones which gives immediate turbidity because it's a cleavage of RO bond. So in alcohols, if you observe, it is the cleavage of RO bond. So greater the bulk of the alkyl groups, more the plus effect, the bonds will break faster. And that's how 3-degree alcohols will give immediate turbidity. Secondary alcohols will give turbidity after some time. And primary alcohols will give turbidity only on prolonged heating. All right. So 98 first statement is correct, but the second one is false. So 1 is correct, but statement 2 is incorrect. So 98 is 3. All right. 99 people is a direct formula based what we have. In fact, no need to solve this also. It says copper crystallizes in FCC unit cells. So for FCC, we know Z is equal to 4. They have given the edge length. You basically make the cube of it. Density is given. They want the atomic mass of copper. We all know atomic mass of copper is 63.5 U over there. So the closest answer to 63.5 is the first one. But if you calculate also 99, it will be the first one only, where the formula density is equal to Z into M upon A cube into Na. But no need to calculate. You can get it directly. Last one, the 101. That's nothing but benzonitrile. First with lithium, aluminum hydride, and water. So this is similar to what we have as Mendes reduction. Cyanide gets converted to primary amine, where carbon chain increases by 1. So CN changes to CH2NH2. Then with NaNO2HCl, the NH2 gets converted to a disonium salt. And then with water, the disonium salt will get converted to its over there, its respective OH group. So there is only one option which makes sense, where carbon atom, one carbon is increasing. So 100 will be the last one. That's 4. So look at that. First, benzonitrile gets converted to its respective benzylamine. Benzylamine with NaNO2HCl gets converted to its benzyl disonium chloride, which with water will give you benzyl alcohol. All right. Okay. Thank you.